Hello, in this video we will generate the binomial series of 1 minus x to the power negative 1 half, generate its expansion in Taylor-Maclaurin series sum, and compare the expansion coefficients with the regression coefficients. So we begin with the binomial series, which is array formula. 1 minus x to the power minus 1 half. And we'll chart this using the scatter chart and show the trend line. This time we'll use the polynomial raised to the power. We use 8 because we want 0 degree of freedom into the equation. The goodness of it here is 1. That's typical for 0 degree of freedom in a polynomial regression. Next, we generate the Taylor-Maclaurin series sum expansion, where it is the summation of a times x to the n, where a is double factorial 2n minus 1 divided by double factorial 2n. And the values of n will start from 0 to infinity. In this case, we're limited to our data set. So the series sum of the Taylor-Maclaurin series sum will be our formula series sum x to the power starting from 0 incremented by 1, and the coefficient will be this range. And we generate the expansion or the trend line for both in polynomial raised to the power 8. So now we have the expansion. Let's work on the coefficient, which is our formula. We begin with the factorial double 2 times n. Let's say just divided by factorial double 2 times n. Okay, now we factor in 2n minus 1, so that's minus 1. Oh, there's an error. This should be 1. So we use if error. So to do that, we will put this in a parenthesis. So this is, we'll add if error, 1. Now we have corrected the error. So you'll notice the coefficients, the regression coefficients are approximately the same. And the data set, they're the same in this area, but error begins within these areas. So there's an error, but they are still in the same trend line. That means the accuracy is still good. We'll calculate the regression coefficients to compare this with our expansion coefficients. We'll use LINEST to do that by generating the 1 minus x matrix. To generate that, we begin with the power. So it is transpose. And because there is no degree of freedom, so we cover the entire rows, the number of rows. That's x to the power 0, x to the power 1, x squared, x cubed, x to the power 4, until x to the power 8. Now we generate the 1 comma x matrix, which is array formula. Array formula of the x values raised to the power from 0 to 8. Now that we have the 1 comma x matrix, we can use LINEST. So LINEST data y and data x. Same thing with expansion. LINEST data y and data x. So our b0 match to a0. b1 also match to b1. b2 same as b2. But the differences as they go higher in degree, but because they are small, it's still negligible. Our b0 here matches to our b0 in the trend line. b1 matches to b1 in the trend line. b2 still matches to our trend line. b3 still match. b4 they do match to our trend line, but the error begins, the differences begins. But these are small values. The error is negligible. This completes the use of the fact double, the if error, in generating the Taylor-Maclaurin series sum expansion of the binomial series of 1 minus x to the power negative 1 half, and comparing it with the regression coefficient using Linus polynomial regression with 0 degree of freedom because the rows and the columns are equal.